Hey mathematicians, let's do our homework. All right, so the front page is exponents and the back page is fractions. Let's start with our exponents. Find the value of each in standard form. If you just write me an answer, then I know you did not do this for real. You just Googled it. So I need to actually see the work and then the answer, which is what standard form means. So 12 to the power of 3 means 12 times 12 times 12. So I need to see your work showing me, oh, 12 times 12, not 24. It's really tempting for a lot of you to write the times symbol and then, oopsie, accidentally add. 12 times 12 is 144. 144 times 12 is not a fact that I know off the top of my head, so I expect to see some kind of scratch work. Personally, I don't like to stack like this. That's not my most efficient strategy. If it's your most efficient strategy, go for it. I personally will do 144 times 10 because 12 is really made up of 10 plus 2. And that gives me 1,440. And then I do 144 times, okay, 10 plus what number makes 12? Because that's what we're really trying to multiply by, times 2. 144 doubled is 288. And then I add those two partial products together to get my final answer. If you would rather stack, that is totally fine. You will end up getting the same answer, but I need to see some kind of scratch work to prove to me that you didn't just like hold your camera over it and do some kind of app that tells you the answer. 4 to the power of 5 means 4 times 4 times 4 times 4 times 4. There are 1, 2, 3, 4, 5 of them. And you are going to do 4 times 4 is 16. Your choice. I personally would probably do 4 times 4 is 16. I know that 16 times 4 is 64. Maybe you want to be doing 16 times 64 and that gets you your final answer. Maybe you want to take it one step at a time because you don't like double-digit multiplication and you'd say 16 times 4. Okay, that answer is 64 times another 4. Get that answer times another 4. However you do it, so long as you are doing 5 multiplication steps of times 4 times whatever, if it's 4 or the 16, whatever it is, you're going to end up with your final answer. We talked about this in class today. Negatives, you can multiply negatives. Negative 3 times negative 3. Notice that you don't need a time symbol if you have parentheses that are smushed together. If you want to put a time symbol, that's fine. But showing you that they're so smushed like that, that is showing you multiplication. So negative 3 times negative 3, oh, that's a positive 9. I personally like to do it like this because I know what 9 times 9 is, and I know that if I keep doing times negative 3 times negative 3, that actually might get harder for me. This one is going to give us a positive 81. So that's what you're doing for each of these. The fractional ones, remember that when you multiply fractions, you multiply the numerators. 4 times, I said the answer. 2 times 2 is 4. 5 times 5 is 25. Don't simplify it. Don't do anything. That's your answer. So actually, I think the fractions are easier than the decimals here. If you're doing this decimal, then maybe you want to do 8 times 8 times 8 and then worry about your decimal afterwards. At the very end, if you do that strategy, you'd move your decimal 1, 2, 3 times to the left. Let's do this one with algebra, with letters. Okay, which have the same value? That means they're worth the same thing. So scanning these, I don't know what x is, which is okay. Oh, I do know that this is 16. I'm guessing that that does not have a whole lot to do with all my x's because it doesn't even have an x in it. So probably not that one. This says x to the 4th power. I know that anything to the 4th power means the base 4 times x times, ooh, notice you probably don't want to do a times symbol that's an x. I'm going to do the dots times x times x times x. This shows me 4 times x. It does not show me 4 x's. It shows me the number 4 times one number, which is x. So these are not equal to each other. So anything that has 1 and 2, that's not right. This is x to the power of 3. X times itself 3 times another x. Ooh, look, they end up looking the same. 1 and 3 are the same. So this one has 1 and 3, and this one has 1 and 3. We already know that this IV, no, 16 has nothing to do with x times x times x times x. So IV is out. Ooh, which looks like it leaves us with option C. Let's just double check. VI is x times x times x times x. Yeah. Oh, but wait. It also says V. Do we agree? X squared means x times x times x times x. Uh-huh. So it's VI, V, I, and I. Those are the ones that are equivalent. On the back. Describe and correct the error. Ooh, this is a mistake. I'm telling you that this is the wrong answer. So don't tell me it's good, because it's wrong. So it's not just telling me what the right answer is. It's telling me what went wrong. So looking at this, I see a 4, I see a 3. 4 times 3, ooh, that's 12. And then 7/10. That's not how we do things. So you can tell me they just multiplied the whole numbers. But then when you tell me the real answer, you need to make both of these fractions and fractions only. So 4 can become 4 over 1. 3 and 7/10. Remember, we do 10 times 3, that's 30, plus 7, that's 37 tenths. And then you're going to multiply those two. Hint, you could simplify that before you multiply. You don't have to, but you could. Oh no, my fraction looks weird. I worked so hard to make them look normal. But I guess that spacing went a little wonky. In an aquarium, 2/5 of the fish are surgeon fish. Probably not real doctors. Surgeon fish. I'm pretty sure that's supposed to be sturgeon fish. I don't know much about fish. Of these, okay, that means of the surgeon fish, 3/4 are yellow tangs. So that's like a type of fish, and 3/4 of that type of fish are yellow. Not all of the fish, not 3/4 of all the fish, but 3/4 of the 2/5. We need to remember this is such a powerful math word right here. Of means we are multiplying. And just for the sake of we're in the algebra unit, I'm going to use a different multiplication symbol than the x. So you are doing 2/5 of 3/4, or rather 3/4 of 2/5. Tell me what that answer is. You go for a long walk. You walk 3/4 of a mile and then sit down to take a rest. Then you walk 3/8 of a mile. How far did you walk? This is an adding problem. You walked this much, and then you sat down, and then you walked this much. And you cannot add fractions that have different denominators. So, if you are a fraction hater, that's fine. No one said your answer had to be a fraction. If you are a super fraction hater and you're like, I don't know how to make them common denominators, make them both decimals. You know how to change fractions to decimals. Maybe you even know what 3/4 is because it's such a common one we deal with. You know how to add decimals. Make sure your decimal point stacks on top of each other. If you do not want to write them as a fraction, which you totally can, by the way. If you don't, that's another option. How many times, okay, thinking we're looking for a multiplicative relationship, longer is the baby alligator than the baby gecko? Okay, so the baby alligator is 3/4 of a foot. I'm just going to put a little A there for alligator. The baby gecko, G, is 2/15. How many times longer is the baby alligator? This one is longer. What do you have to do to get this answer? Ooh, wait a minute. How can you solve a times problem? One way to solve your times problem is to do the inverse, to do the opposite. So if you are multiplying times 2/5, then you can divide both sides by 2/5. No, sorry, not 2/5, 2/15. Divide them or multiply by the reciprocal. So you are setting this problem up. So remember your keep, change, and flip. Last problem, you just need to explain your answer. You do not need to show me math. You are telling me yes or no. Is this product, is this answer bigger or smaller than 1/6? So you can use your reasoning about this fraction being bigger or smaller than 1 to help you find your final answer.